A very good morning to all present here. I, Asmita Singh, Research Scholar, Department of Chemistry, University of Lucknow, would like to welcome my examiner, Professor Ramendra Singh from University of Lucknow, our Head of Department, Professor Anil Mishra sir, our ex-Head of Department, Professor Naveen Khare sir, my guide, Professor Arun Sethi sir, all the respected faculty members, and my fellow scholars. Today, I will be giving the presentation to defend my thesis on the topic synthesis and characterization of novel steroidal derivatives as potential biologically active agents. My presentation consists of following chapters, including introduction, scheme for the synthesis of derivatives, computational studies, molecular docking, and biological activity of selected compounds. I would like to start with a brief introduction about steroid. These are naturally occurring tetracyclic carbon containing compounds. In this, their core structure is formed of 17 carbon linked together to form a 4-fused ring, in which 3 rings are 6-membered and the 4th ring is 5-membered. The presence of methyl group at C13 and C10 position, designated as 18 methyl and 19 methyl. Then classification of steroid. Steroid possessing a side chain or a group at C17 position is the basis of classification of steroid into following classes: estrane, androstane, pregnane, choline, cholestane, spirostane, ergostane, stigmastane, and miscellaneous. I have discussed only few of the classes about on the compound that I have worked on. One is estrane. These consist compounds having the methyl group present at C13 position, and this class consists of groups known as estrogens. Their structure varies due to the presence of aromaticity in ring A and the presence of hydroxyl or carbonyl group at potential positions. Next is androstane. Presence of methyl group at C10 and C13 position. This class is also considered to be the precursor to other steroid, and variation in this structure is attributed to the presence of carbonyl or hydroxyl group at potential positions. Next is pregnane. Presence of methyl group at C10 and C13 position, as well as a 2-carbon side chain present at C17 position, and this is further classified into 2 different classes: progestins and corticosteroids. Common example of this class is pregnenolone, progesterone, hydrocortisone, prednisolone, methylprednisolone, and corticosteroid. And I have worked on pregnenolone and hydrocortisone. Next is cholestane. Presence of methyl group at C10 and C13 position with a 7 to 8 carbon side chain at C17 position. And the important group of this class is sterol, and the most important compound is cholesterol. Next is spirostane. Presence of methyl group at C10 and C13 position, and a spiroketal ring fused to ring D, and important compound of this class is digenine. Next is synthesis of derivatives. Scheme 1. In this scheme, I have synthesized total 6 compounds, 5 compounds from digenine. The compound 3 is 16 dPa, which is synthesized using acetic anhydride in pyridine, and then sodium methoxide I have synthesized compound 4 from compound 3, and then under reflux condition in methanolic potassium hydroxide I have synthesized compound 5, which is the introduced methoxy group at C16 position. To this 5th compound I have carried out with Stiglitz esterification in presence of DCC, DMAP at room temperature in chloroform to yield compound 6. This is the characterization detail of compound 2. I have only carried out with 1H-NMR and 13C-NMR. In compound 3, 1H-NMR, 13C-NMR and ESI-MS confirm the formation of compound 3. In compound 4, only 1H-NMR was carried out to understand that hydroxyl group has replaced the acetyl group. In compound 4, 1H-NMR and FTIR was carried out to check whether the desired compound has been synthesized or not. In compound number 6, 1H, 13C-NMR, FTIR and ESI-MS was carried out to check the synthesis of desired compound. In scheme 2, from compound number 7, that is pregnenolone, I have carried out with Stiglitz esterification to synthesize compound number 8, 9 and 10 with with protonic acid, cinnamic acid and mefenamic acid to yield compound 8, 9 and 10. To further 8 and 9 and 10 compound are carried out with reduction with sodium borohydride in methanol to yield compound 11 and 12. And compound 11 was further esterified due to the presence of hydroxyl group at C20 position. I further proceeded with esterification in presence of DCC, DMAP in chloroform at room temperature with naproxen and mefenamic acid. In compound number 8, I have carried out with for characterization 1H13C-NMR, FTIR and ESIS. In compound number 9, to check the established product whether it is formed or not, 1H-NMR, 13C-NMR, FTIR and ESIS was carried out. In compound number 10 also, 1H-NMR, 13C, FTIR and ESIS was carried out to check the synthesis of the desired compound. Compound number 11. Compound number 11 is the to check the whether the reduction has taken place from compound number 9 and 10. I have carried out 1H-NMR, 13C, FTIR and ESIS was carried out to check whether the reduction has taken place at C20 position or not. Similarly, at compound number 12, to check out the reduction at C20 position, 1H-NMR, 13C, FTIR and ESIS was carried out. Compound number 13, after reduction are carried out with esterification with mefenamic acid to introduction of aromaticity at aromatic region in both 1H-NMR and 13C-NMR confirms the formation of desired compound. In compound number 14 also, introduction of aromatic region confirms the formation of desired compound. Scheme number 3, from in previous scheme I have synthesized compound number 8 by introduction of a double bond makes it an eligible candidate for Heck coupling. So I have carried out with Heck coupling in presence of PD catalyst, K2CO3 and DMF as a choice of solvent with 3-bromotoluene to yield compound number 15, which was further reduced in presence of sodium borohydride and in ethyl acetate to give hydroxyl group at C20 position, which was further esterified with naproxen in presence of DCC, DMAP in chloroform at room temperature. Compound number 15, to check the synthesized compound, I have carried out with 1H-NMR, 13C-NMR, FTIR and ESIS. Introduction of aromatic region in both 1H-NMR, 13C-NMR and formation of molecule and peak in ESIS confirms the formation of a desired compound. Compound number 16. In compound number 16, I proceeded with reduction at C20 position. To confirm the reduction has taken place, I have carried out with 1H-NMR, 13C, ESIS, which confirms the formation of desired compound. Compound number 17, after reduction, I proceeded with naproxen. So already there was aromatic group present in there. So further, more peaks for aromatic region were observed attributed to the naproxen moiety, which confirms the formation of the desired compound. In scheme 4, compound number 18, which is cholesterol, I have esterified it with 3 different types of acids, cyanoacetic acid, ketodolaf and NSAID, and 3-bromobenzoic acid to yield compound 19, 20 and 21 in presence of DCC, DMAP in chloroform at room temperature. For compound number 19, 1H-NMR, 13C-NMR, FTIR and ESIS was carried out, and introduction of aromaticity in both 1H and 13C confirms the formation of our desired compound. In compound number 20, 1H-NMR, 13C-NMR, IR and ESIS were carried out to characterize the synthesized compound and introduction
कोई
of
एक कंपाउंड को प्रूव करके बता सकते बच्चे, स्ट्रक्चर प्रूव करके बता,
So NMR इसी के
इसी
थ्रू
से सब पूरा प्रूव करो स्ट्रक्चर.
ठीक है सर. इसी इसमें in this one compound number 20, introduction of cyano group was confirmed. Esterification was confirmed by the shift of methine proton at C3 position, where peak was observed at 4.6 for 4.69 for one hydrogen, and at 3.43 for the cyano for the carbon that was attached to the cyano group, which confirms the formation of a desired compound that the cyano group was present.
13C में IR में मास सब बता.
In 13C NMR, for that after the esterification was carried out at peak at 162.31 for C28 carbonyl group was observed, and for 113.18 for C30 carbon was observed, and for C3 carbon downfield shifting 73.92 was observed, which confirmed that acidification has been carried out. In FTIR also, triple bond C was confirmed by peak was observed around 2900 and acidification around 1711, and under CO bond was confirmed by 1191. And in ASIMS, molecular ion peak was observed at 453. In compound number 21, there was also aromaticity was introduced. So it confirmed that the compound aromatic group is present. Also, NH group was there in the compound that I have attached to the original compound. So which confirmed that the synthesized compound has desired compound has been synthesized. In scheme number 5, in scheme number 5, compound 22, that is hydrocortisone, was acidified with 3 different NSAIDs in presence of DCC, DMFE, and chloroform at room temperature. And at C20 position, the hydroxyl group was acidified with these different NSAIDs. In compound 23, the presence of aromaticity and peak for NH was observed in both 1H-NMR, 13C-NMR, and in ESIMS, molecular ion peak was not observed. Instead, molecular ion plus 2 hydrogen peak was observed, which confirmed the formation of a desired compound. In compound 24, aromaticity due to naproxen moiety was introduced in both in 1H-NMR, 13C-NMR, and in FTIR is carbonyl group for CO, and in the ester group, carbonyl and CO single bond was observed at 1718, 1656, and 1270, which confirmed the formation of our desired compound. In compound 25, also there was aromaticity introduced with amino group introduced at 8.9, which confirmed the formation of our desired compound through 1H-NMR and both in 13C-NMR. In FTIR, primary amine was observed at around 3325, and acidified carbonyl was at 1722.
इसमें कौन सा है ग्रुप है आईआर में? अमीन प्राइमरी अमीन का कौन सा ग्रुप है दिखाओ? ब्लैक बोर्ड उस पे दिखाओ स्क्रीन पे.
In the middle. So this is secondary.
आईआर में दिखाओ कहाँ है?
So it's 3325.
इस पे कहाँ है?
So the first peak. The pointer.
दिया तो था. In ASIMS, molecular ion peak was not observed. Instead, protonated molecular ion was observed, which confirmed the formation of desired compound. In scheme 6, digenine was treated with succinic anhydride in presence of DCC DMAP in chloroform at room temperature to yield compound 26. This also introduces an acidic moiety, which prompts us to react it with compound 27, which is dihydroepiandrosterone DHEA, to yield compound 28. In this moiety, both sides of the succinic anhydride is a steroid moiety, whereas in previous all other compounds there was a steroid moiety with NSAID group. In compound 26, the H3 methine was shifted at 4.6.
स्क्रीन पे आगे बढ़ाओ.
तो बढ़ा दिया है. H3 methyl group was shifted to 4.60 and H29 at 2.61. For H29 and H34, these H29 and H30 peaks confirm the formation of the desired compound in 1H-NMR. In 13C-NMR also, C31, that is the acid group 174.71, and carbonyl compound, carbonyl group CO of the ester bond at 171.65 was observed, and C3 carbon shifts to 74.46, which confirmed the formation of the desired compound. In compound 28,
वहाँ नहीं स्क्रीन पे नहीं आ रहा है.
in compound 28, both the steroid presence was confirmed by the
after DHA was attached to the acid group of the diazine with succinic anhydride, its carbonyl group was found at 209.49, which confirms that the DHA moiety has been attached to the succinic anhydride group, acid group of the diazine, which confirms the formation of our desired compound number 28. Scheme 7, in this compound 27, that is dihydroepiandrosterone, DHA, was esterified with 5 different NSAIDs, 4 different NSAIDs and a acid, protonic acid, ibuprofen, naproxen, mefenamic acid, etodolac and protonic acid in presence of DCC, DMAP in chloroform at room temperature to yield compound 29, 30, 31, 32 and 33. Compound 29, the formation of compound 29 was confirmed by the presence of aromaticity both in 1H-NMR and 13C-NMR, and in FTIR, presence of carbonyl group, esterified carbonyl group at 1727 and CO bond at 1247 confirm the formation of the desired compound. Compound number 30, also in this one, aromaticity was introduced, which was found between 7.67 to 7.10 range, which confirmed that aromatic group has been introduced. Also, methoxy group was present at 3.90, which is a group attached to the naproxen moiety, which confirmed that the desired compound has been formed. In compound 31, aromaticity was introduced with amine group, which confirmed the formation of the desired compound in 1H13C, FTIR and ASINS. Compound 32. In this compound, presence of the NH group at 9.19 and aromaticity in the range of 7.35 to 7.01 confirm the formation of the desired compound. Compound 33. In this compound, the formation of was confirmed by the presence of double bond observed at 6.97.
Please move ahead of synthesis.
Yes, sir.
Move ahead of synthesis.
Stick to the last scheme.
लास्ट सिंथेसिस दिखा के उसके बाद आपने क्या काम किया बता, लास्ट वाला दिखाओ स्लाइड, स्कीम कौन सी है?
In my last scheme, I have carried out
इस पे तो
Sonakshira
दिखाओ,
coupling.
स्क्रीन पे तो दिखाओ.
In my last scheme, I have carried out Sonakshira coupling on compound 37, that is northeastern due to the presence of a terminal alkyne group in presence of palladium catalyst, K2C3 as a base, in DMF as a solvent, and reflux at 140 degrees centigrade with 2 bromotoluene, 3 bromotoluene and 4 bromotoluene to yield compound 42, 43 and 44. Due to the presence of a free hydroxyl group, I have also tried to carry out the Steglis esterification with different NSAIDs, starting with the smallest moiety and then increasing toward the size. But none of the compound gave esterified compound, which proves that, which may be attributed that the steric hindrance or the bulky group of the acid group is not able to attack the hydroxyl group, which confers the formation of the desired compounds after esterification.
आगे करो इसको, आगे करो. बताइए आप.
I have carried out computational studies of only selected compounds, that is compound 22, 23, 24 and 25. This is the figure for the optimized structure that was used for all the computational studies that we carried out, that is 1H-NMR, IR, UV, HOMO, LUMO, and to plot MEP graphs. This table shows the HOMO to LUMO transition for in UV visible region, and this shows that our transition is in the phase of pi to pi antibonding region. And these values that I have observed in the calculation one corroborated with the values that I have got from the experimental lab. This figure shows the difference between the HOMO-LUMO orbitals of the compound that was used for the computation study. Then vibration assignments. In this, the values that I have obtained corroborated with the values that I have obtained from the experimental values. Molecular statostatic potential. In this one, in molecular statostatic potential, I have achieved that these colored figures show that which portion of the compound shows more positive and more electronegative region of the compound. This is the table for the calculated hyperpolarizability, polarizability and other properties which are useful to understand the analog properties of the synthesized compound, which show that our in the value I have obtained in these tables shows that our compound was good as a analog material. Then molecular docking. For compound 19, 20 and 21, molecular docking on human placental aromatase protein was used for this. For the PDB ID for this protein was 4GL7, and these are the binding mode of the compound that is observed on the protein. The values I have obtained in this for the synthesized compound shows that I have also docked the initial compound 18, that is cholesterol, for a comparison with the synthesized compound, and the values I have obtained shows that compound number 21, no, it's compound number 20 with minus 8.69 value, it shows better coordination with the protein instead than its other synthesized compound and the starting material cholesterol. So the same compounds 18, 19, 20 and 21, another docking study was carried out but with different proteins, that is human cyclin B1, PDB ID 2B9R, and human cyclin dependent kinase 2, PDB ID 1B38. The values of the binding energies that I have achieved in this docking study shows that in human cyclin B1, compound 21 shows better binding affinity with the protein rather than the starting material and other synthesized compound, and human cyclin dependent kinase 2, the compound number 21 shows better binding affinity with the protein in comparison with its other synthesized compound or the parent compound. The following structure shows the binding mode with the protein. And also human serum albumin, compound number 37, 38, 39, 40, 41, 42, 43 and 44, that is all the derivatives that I have synthesized for norethistone by esterification and by Sonagashira coupling were docked on human serum albumin protein to understand its binding with this protein. Two different proteins for this was choose, for it was 2BHD and the next one was 2BHD. Then biological activity. Also biological activity, I have carried out biological activity for compound 23, 24 and 25. But for comparison, I have also docked the parent compound 22, that is hydrocortisone. And this activity was carried out for anti-inflammation. And first the cell viability was checked. In this, it was found that compound 24 was cytotoxic for the cells, and compound 22, that is initial, and other two synthesized compound 23 and 24 and 25 were better for the anti-inflammation activity. In the anti-inflammation activity, IL-6 and TNF alpha concentrations were calculated to understand the anti-inflammation activity. Then evaluation of anti-cancer activity, compound 37, that is the initial compound norethistone, and its derivative 38, 39, 40, 41, 42, 43 and 44 were checked for their cell viability, in which compound 40 was very cytotoxic for the cell line, and this activity was carried out on HeLa cancer cells. And in anti-cancer activity, compound 38 was found to be better. 38 and 41 was found to be better than the initial compound 37. This is the list of publications that I have published during the course of my work. References I have used to carry out all this work. And acknowledgement, I would like to thank all the faculty members and the head of department, my guide, and fellow scholars for helping me regarding this whole course of my PhD.
So, you made nice presentation, right? And show your confidence in your work.